The ore body, 500 feet in width and 1,200 feet in length, is located some 600 feet below the peak of the mountain, but it dips at a 45-degree angle under the peak, which accounts for the large tonnage of waste rock to be removed before the ore body is completely exposed for open pit mining. From the lower levels above the ore, the trucks wind up the steep curving road to dump their loads of waste down the slopes, where there are patches of perpetual snow and small glacial lakes. Rocks that are too big for the jaws of the shovel to handle are loaded with packs of explosive and blasted into smaller chunks. All loose and overhanging rocks are scaled by men who look like alpine climbers against the sky. Down on the ore bench, the veins of serpentine are easily visible and range up to 3 inches in width, making this mine one of the richest long fiber asbestos mines in the world. Geologists continually sample each new face of ore to determine the quantity and quality of the ore present in the formation. The green shimmer of a fresh-picked sample indicates the richness of this magic mineral. Asbestos is the product of nature's factory and has unique qualities, for it will neither burn nor decay and is impervious to water. As the ore body is stripped of waste and overburden, large areas of the bench are drilled. The holes are loaded with explosive, fused with a combustible fuse to eliminate blasting wire that contaminates the ore. The asbestos ore breaks up readily and is easily handled by diesel-powered shovels. A fleet of trucks have a short haul from the ore bench to the crusher house. The trucks empty their loads of ore onto a grizzly. Here, the large chunks are broken up with a pneumatic drill. Below the grizzly is the primary crusher, where the ore is crushed to approximately 4-inch size and dropped to a surge pile. From here, the ore is withdrawn to a rock rejection circuit, consisting of a crusher and 3 screens between the primary crusher at the mine and the head of the tram line to effect a partial concentration of the ore prior to delivery to the tram line. These buckets travel about 3 miles in their circuit from mine to mill. The loaded buckets pass over a trip switch, which releases a bucket every 27 seconds for its downward descent to the mill. The rock rejection plant above the loading chute screens out about 25% of barren serpentine rock, thereby supplying a larger percentage of fiber to the mill. The upper section of the tram line is about 2,500 feet higher than the unloading station at the mill. Each bucket carries about 3/4 of a ton, and the maximum capacity of the tram is about 2,400 tons per day. In the valley close to the town site is the mill. The loaded buckets on the tram line dump their loads into a hopper. The empty buckets go around over piles of storage ore that can supply the mill in any emergency. The pre-crushed ore dumped into the hopper drops over a grizzly. An endless belt carries the ore to the mill crusher, which gives the final crushing before conveying it to the dryers. In these long cylindrical dryers, a continuous flow of ore goes in to be dried by the roaring oil-heated furnaces. As the ore has a high water content, particularly at the beginning and end of the mining season when rain and snow are prevalent, drying is essential to store the ore at the correct moisture content. With the moisture removed, the ore is then ready for the dry rock storage shed. This storage supplies the mill with dried ore for further processing. The ore is drawn from the dry rock storage on an underground conveyor to meet mill requirements. To separate the crushed ore, it first goes over a series of shaker screens, and the fiber is separated from the rock. Fiber is removed from the shaker screens by air suction into collectors. The remaining rock and fiber that has dropped through the first screens continues on through a series of finer shaker screens and collectors to remove all fiber. Cassiar engineers developed a cylindrical screen that whirls the fiber until all impurities are removed. The finished fiber is carried to the collectors above. All remaining pieces of rock and ore from the last series of shakers are put through a fine crusher so that the last remaining fiber can be extracted on finer shaker screens. And waste from this process is carried by conveyor to the tailings pile outside the mill. When the fiber has been cleaned of all rock and dust, it is separated into grades of different fiber lengths and collected into bins above the bagging department. The fiber comes down chutes to the bagging machines. All bags are clearly marked with the grade of fiber, and each bag is weighed to contain 100 pounds of compressed fiber. The bag is then sewn up and is piled on pallets holding 20 bags each, ready for the shipping and storage shed. A dust collecting system filters the air for recirculation through the mill. Each batch of fibers that has been milled is sent to the laboratory to determine the grade and quality. Realizing the importance of constant grades in asbestos milling, the Quebec standard machine was adopted and 7 other quality control tests were developed. computer web combing test, the percentage of long fibers from the sample is determined and weighed. The Bauer-McNett test was patterned from the same wet classification test used in the paper industry. Continuous testing ensures a product of uniform quality for the world market. The pallets of bags are moved into the warehouse, where they are either stored or loaded on company-owned semi-trailer vans. These trucks are designed to haul bagged asbestos fiber to Whitehorse, and on their return trip, they haul fuel oil in special tanks mounted on the underside of the van, as well as other supplies. They always leave in convoy down the Cassiar Road, which connects with the Alaska Highway on the long haulage route to Whitehorse in the Yukon. At Whitehorse, it is warehoused ready for reshipment by rail to Skagway, where it is loaded on freighters and sent down to Vancouver. The fiber is unloaded at the docks in Vancouver and stored in large company warehouses to await shipment to many industries throughout the world. Nature created asbestos, but science has been making it serve mankind since man has learned to put it to use. Nature has challenged man in its recovery. Through fog and rain, snow and blizzards, short hours of light in winter and short hours of darkness in summer, the work goes on despite these variables. In the long twilight hours of a summer's night, the grandeur of the mountains is punctuated by the steady throb of the engines that run the drills, by the clank of a shovel as it digs into a rock face to spew a load of muck into a waiting truck, as other trucks rumble along the mountain roads. When the top of the mountain has been sheared off and the great ore body of asbestos is laid bare, these truck drivers or their descendants will still be hauling out ore for the mill. Nature has been good to the men who first found and developed the mine, for they are sure there is ore in good supply for at least a half a century ahead. And this wonder mineral that was once the bedding down place for mountain sheep will find its way down the Cassiar Road to new places for new uses that will be conjured up by men of vision in our world of tomorrow.